Hey guys, welcome to Extreme IE. In this video, we're going to take a look at tetration data collection. We want to look at what tetration is collecting, but more importantly, we want to understand why tetration is collecting this. So a lot of our competitors will come along and say, you know, we're going to deploy a software sensor everywhere, and it's going to give us everything that we need. What if you can't deploy a software sensor? What if you have a mainframe? What if you have a phone system? What if you have a hardened Linux appliance like a web filter, an email filter, a NAS unit, for example, some type of storage unit? How do you enforce inbound policy on those devices? How do you even gain visibility on those devices when you cannot deploy a software sensor there? You know, deploying software sensors is not the only factor in gaining visibility into your infrastructure, right? There are other ways and mechanisms. The other factor to think about is that most of these software sensors are really just Wireshark on steroids, right? They have a nicer user interface. They're not as raw as Wireshark. You don't maybe necessarily need to understand how to do a packet walk with Wireshark like you would with Wireshark. But they really don't give you any more data than Wireshark. You're getting source destination protocol, and that's it. Right? Other competitors come along and say, well, we don't deploy any software sensors. We're going to do everything at the network. We're going to just deploy network sensors everywhere, NetFlow everywhere, right? Distributed firewalls, and we're good. The problem is that both of these mechanisms on their own really don't give you anything more than, again, what you can gain for free. And they leave so many gaps. For example, NetFlow is a great tool to gain, you know, top talkers and network telemetry. The problem is that when it comes to creating a policy in your network of who should talk to what and why, NetFlow lacks directionality. It doesn't give you who started the conversation, who ended the conversation. It doesn't give you all of that. It just gives you, hey, two things are talking on these ports. That's it. It doesn't tell you why. So let me give you a quick example here. Let me grab my pen. If I have a web server, right, we'll say web 1 talking to DB1, right? That's great that I can see this conversation happening on port 1433, and I could guess that this is MS SQL, but do I really know why these servers are having a conversation? No, I don't. I just see that they're having a conversation. I'll give you a real world example. What I see in my environments and my customers a lot is customers running Tanium, and this is a great product for customers to run. If you're not running Tanium, I do encourage you to look into it. And Tanium typically uses 174.7.2. I have seen customers use or see a lot of this traffic on 71, but generally I see 174.72. Now, this is a higher port, right? And there is a lot of sometimes cross communication on a network. Now, if you're just running one of these glorified software sensors, you're just going to see this port. And unless you know that port off the top of your head, you're going to have no idea what this is. You're just going to know that you see it happening. And you may find yourself in a position where you're allowing traffic that you don't want to allow or that you shouldn't allow, but you don't know what it is. Or you're blocking traffic that you should allow and you have no idea what it is. Tetration actually combines both of these worlds and allows us to have much more context around what we're gathering and how we're gathering it. Let's just pick on DNS, for example. In your environment right now, you have DNS servers that have all of your subnet information, all of what you're handing out via DHCP. It has all that information within DNS, right? You know all of your workload IP addresses. You know this is your web servers and all that kind of stuff. You have the URLs, the A records, you know, all of that you have in DNS. Well, tetration allows you to take that information in DNS and then pump it into tetration so that tetration can begin to ingest your DNS and understand what subnets are what and what things are where. Any good VMware admin, when they go in vCenter and they deploy workloads, they're going to start tagging them or labeling them. They're going to start saying, hey, what are they? Are they production? Are they development? Are they QA? Are they database servers? Can you give me something? What data center are they located in? And you can automatically synchronize tetration with that information. So are we running a software sensor? Yes, we are. Do we also support other mechanisms of collection? Yes, we do. For example, we are going to integrate with your load balancers out of the box. So when you have an inbound flow coming into a load balancer, and then from that load balancer, that traffic goes out to a web server, right? We're going to be able to capture data from both of these entities or resources within your network. And then we're going to be able to, again, feed that information into Tetration. So it's not just deploying a software sensor everywhere, because that doesn't always give you everything that you need, right? There are many, many occasions where you need to understand other context about your workloads. Think about containers, for example. Think about K8s or Kubernetes, right? I'll say K8s to keep it short. When Kubernetes as an orchestrator is turning up containers, let's just say that in Kubernetes you said, hey, I need a minimum of 3 web servers all the time and 2 database servers all the time. As Kubernetes is spinning up those nodes, and let's say that you lose one container and all of a sudden Kubernetes turns up another container on another worker node, you want to be able to understand when that's taking place. You want to be able to understand how those changes are occurring in your environment. And again, you can integrate Kubernetes with Tetration so that you understand those changes within your infrastructure. But I'm going to pick on 2 big ones here, AnyConnect and Ice for a minute. You have users that are coming into your network. They're logging into your networks, and sometimes they're a guest and sometimes they're an employee. And then they access that web server within your environment. They access that web server that's living within your data center. And then, of course, that web server hits the database server, and maybe it hits, the AD server for some type of, additional authentication. Let's say you don't have single sign-on or something. That user that's authenticating could be authenticating against Ice. And again, Ice automatically integrates with Tetration so that now I understand the user context of how that user and when that user is accessing my application. So when I go to create a policy on this web server, when I go to create a policy on that load balancer, let's put load balancer here, I know exactly how this application is being used, when it's being used, how it's being used, and what that baseline looks like, right? Think about the other labels that maybe you have in ServiceNow or any other CMDB that you have in your environment where you've labeled things like production and development and maybe the different business units that own specific applications. For example, this could be human resources or this could be finance. So now when it comes to actually creating a policy, if I start combining all of these things and start feeding them into Tetration, now I can actually write a policy that's not only based on what could be the user's LDAP group, but also based on how the application actually is running today. So for example, if the LDAP group equals HR, then I'm going to allow that user access to the HR application. This could be coming from ServiceNow, this could be coming from ICE, this could be coming from DNS as well as vCenter. And so we are taking in all these different resources that have your information and different pieces of information, and we're combining them into a single system of record. And I think this is really important for you to understand. Now, as we take in all this data and we combine it, we want to start building what we call a workload profile within your Tetration cluster. Oop, I picked the eraser and I wanted the pen. We start building what's called a workload profile. And we'll look at this in the demo, whether we do it in this video or another video, depends on how long this video comes out to be. Regardless, I'll show you what the workload profile looks like, but we're gaining so much more information than just source destination protocol. For one thing, we're gaining long-lived processes. This is any process that lives for longer than 5 minutes. So imagine that I want to understand, okay, I have a web server, and that web server is accessing a database server, but what is it on this web server that makes it a web server? You can tell me that I have 443 open, and that's great, but is it really a web server? I want to know and see that it's Apache that's actually running or listening in on port 443. I want to understand that it's the Apache service that's actually then reaching out to this database server on 1433, and that it's actually MS SQL that's listening into inbound connections on port 443. So I don't just want to understand that I need to open up port 1433 or that I need to open up 443. I want to ensure that it is in fact the right services, the right software versions that are running on these particular servers before I just open myself up. And that brings me to the installed packages. Tetration is going to also take an inventory of everything that's installed on your workloads within your data center. So I'm going to be able to see that it is in fact Microsoft SQL. I'm going to be able to see that it is Apache and the version. This allows me to not only do version control within my environment, but also create policy around version control. So maybe on this particular database server, I am only going to allow a specific version of Apache access to that particular database server. Why? Because I want to make sure that I am secure. I want to make sure that people don't just start making random changes in my environment. I want to make sure that an attacker doesn't nail this web server and then, quickly in the middle of the night, take down that version of Apache, install another version that maybe is more susceptible to an attack or something like that, gives that attacker more ability to attack my environment, quickly turn Apache right back on. We see a glitch in the network, but Apache looks fine to us and no problems. No, I want to actually do a policy based on software version, right? But that leads me down to the next point, right? How do I do behavioral detection within my environment? How do I actually understand that a server is no longer behaving the way that it normally would? Well, that's where tetration comes in with what we call a process snapshot. So the ability to actually capture what a server is doing day in and day out on a normal basis. This allows us to detect when a server is no longer doing or acting appropriately. So again, and we're going to take a look at this in a little bit more depth, there are many things that tetration is capturing that is above and beyond just source destination protocol, right? Our software sensor and our other mechanisms of data collection, which we're going to jump right into now, are drastically different than what most of our competitors, in fact, all of our competitors capture. And what's really important is that we're doing this in one product. We're doing this with one sensor. One of our largest competitors when it comes to this space will require that you run 4 different products and 3 different agents in order to accommodate what tetration is doing. I mean, think about that, right? A lot of people get up in arms that sometimes we'll say, hey, you should run a software agent here. And they say, well, we don't want to do that. And then they go to one of our competitors and they buy a competitor solution and it's, well, hey, guess what? Now you don't just need to run 1 sensor, you need to run 3. Oh, hey, guess what? You're not just going to buy 1 product like you would have with tetration. You're going to have to buy 4 different products. And so now you're in the mode where you gotta combine what you're seeing in output of 4 different products that you would just be able to see in one tetration, right? So here are the different sensors that we support, and here's essentially what they collect and what they do. So the first thing is what we call the full visibility sensor. This is what's going to give you all of the in-depth information around your network conversation, right? You're going to be able to see things like latency. You're going to be able to see dropped packets. You're going to be able to see when you have a problem in your network. And not just that, you're going to be able to put together a very fine-grained policy that you can have a high confidence in is actually correct. We're also going to identify open, used, and unused ports. What does this mean? Well, I run into a lot of my customers with tetration where we see NTP, we see 123, we see NTP running, and we see port 123 open. And I ask, hey, is that a network time server? And they say, no, it's a Linux server and we didn't realize it was running. You would be shocked at how many times people turn up a server, leave it as its default configuration, and services are running, ports are open, but the customer has no idea, right? And in a traditional setting, you may see traffic going to and from that port, you may not, but in a traditional setting, you would just allow that port, right? It's open, we probably need it and we just allow it, right? Or you would say, hey, that port's open, but we don't know if we're using it or not, let's just block it, and then you break something. Tetration is gonna actually identify what's open and used versus unused and open. We're also gonna be able to get, again, the process name. So again, it's identifying that, hey, it's not just some random service running over port 123 or port 80. Hey, we didn't just turn on just one port and we didn't just turn on a service and mask it by running it over port 80. We're gonna actually be able to identify that it is Apache or it is IIS or hey, it's Microsoft SQL running over port 80. And we're gonna be able to identify the version. We also identify user access to the box, right? And again, this is big when you want to start doing user level access policies and say, hey, we don't want to allow this user, no matter where they're coming from, ever access to the box. We also do the installed packages and we correlate that to whatever the CVE exposure is, which means vulnerabilities. I have another video on my YouTube channel. It's called Proactive Vulnerability Segmentation, where I dive a little bit more into that. So definitely go and check that out. But again, what if you can't supply a software sensor? What if it's a hardened Linux appliance? Again, a phone system that we're trying to protect. What if it's a mainframe? What if it is something where, you know what, it's not even that we're not allowed to deploy a software sensor, it's just it's not supported. Well, we also support EER Spam. So if we have a switch in the middle or we have a switch that's connected to that device, again, doesn't matter if it's a Cisco switch, virtual switch, doesn't matter. As long as it supports EER Spam, we can go ahead and we can get an EER Spam session and we can crank that into tetration. So very, very easy can we do that, right? We just simply get source destination protocol, we get the per packet metadata, and we send that into tetration. This essentially allows us to paint a picture of what conversations are happening in your environment. But now let's say that you're actually running Cisco hardware. Let's say that you have a Nexus 9K deployment in your environment, right? You can actually take that flow, you can take all the flows that go through that Nexus 9K and you can send them right into tetration. This actually comes from the flow table within the 9K. So we're not actually deploying a sensor, so to speak. All we're doing is we're asking the 9K to tell us everything that's going on or everything that's going through it. We also support AnyConnect NVM. Wow, what does that do? Well, this is not AnyConnect VPN, right? A lot of times customers get confused on this and they say, well, we're not going to put AnyConnect on a desktop. Why not? We're not talking about AnyConnect VPN. AnyConnect is a software wrapper. It's basically a wrapper. It's a term, you know, AnyConnect, but AnyConnect is a wrapper for a larger software suite. There's a lot of different modules within AnyConnect. An NVM, Network Visibility Module, is just one entity within AnyConnect. And this allows us to get some really cool user data from that endpoint that's running in the campus. For example, let's talk about user identity and LDAP information, for example. So I can actually see that it's JP and his LDAP information or his group membership is HR, and he's accessing the HR web server at 2 a.m. and then that web server is going off to the database server. Do I want to allow this or deny it? In fact, in the future, maybe I want to allow HR but deny JP access to that HR application, and it doesn't matter where he logs into. It doesn't matter whether he's on a laptop, desktop, IoT device. Doesn't matter what data center he's in. I'm talking to myself in third person. It's a little silly. Doesn't matter what data center I'm in. Doesn't matter whether I come in on a Cisco infrastructure, a Netgear infrastructure, a Juniper infrastructure, Arista. It just hypervisor. It just doesn't matter because we're taking in the user data from the device that I'm logging into the network from. And oh, by the way, we also get the process. So I would be able to see that JP, that's supposed to be an E by the way, logged into that HR portal using Internet Explorer or using Google Chrome. So there's a lot of not only visibility here that tells us what's going on in our infrastructure, but again, it's all about policy. It's all about being able to create a realistic policy that actually makes sense and allows me to truly secure my environment, my applications, my data center, and gives me the right information I need in order to truly do that. But again, we also support NetFlow, right? We also support AWS CloudWatch. So if you have, a lot of people say, well, I can't install, an agent, maybe I'm doing serverless, right, in AWS. Okay, that's fine. We can use AWS CloudWatch. We can deploy a sensor within AWS and we can gain all of the flows that are going through maybe your different AWS servers or serverless or whatever, right? As long as we can get a log going to CloudWatch, we can gain that data and we can give you essentially what's talking to it. And then don't forget the load balancers. I kind of addressed this a little bit already, but the idea that we can actually gain the inbound flow information as well as the outbound information from these load balancers. So we can see that maybe this is port 80 and on the back end, maybe it's 8081. And then we can paint that full picture that this is going to web 1 and then web 1 is talking to DB2, whatever it is, guys. The point is that again, it's not just a software sensor everywhere. And it's also not just network collection everywhere. To achieve full visibility, you really need a combination of both. You really need to be able to put all the different pieces together, your network infrastructure plus your application infrastructure, to understand how things are happening in your environment. But I want to talk about enforcement again, or for a second, because again, it's all about policy, right? I want to be able to enforce a policy. I want to be able to say, hey, I'm going to allow port 80 into this F5, and then, hey, port 8081 is going to be allowed outbound going to this web server. Not only do I want to know when that's not taking place, for example, if I have a misconfigured load balancer, but I also want to be able to enforce this policy. Well, a lot of our competitors come in and say, well, you can only enforce it at the network layer, right? So you can only enforce it maybe on a physical firewall somewhere, or you can only enforce it on the, on a distributed switch, on a virtual switch. Other competitors come in and say, well, you can only enforce it at the software sensor on that web server. Tetration allows you flexibility to be able to do both. I can actually, or all three I should say, I can enforce an inbound policy at the load balancer. So I can say only allow port 80 in on this load balancer, and then only allow port 8081 out going to this web server. Simultaneously, if I had a firewall in the middle, I could also push policy out to that firewall if I wanted to have an extra level of security, while simultaneously pushing that policy to that web server so that I have multiple different areas or multiple different layers of security within that application. So again, it's not just one or the other. So many vendors and competitors to Cisco and to Tetration, they say, well, you have to do this, or you have to do this. And I feel like so many people don't like Cisco in the world, let's be honest, that they're like, nope, we're gonna go with this competitor just because, when in reality, you're making your lives much worse. This is quite possibly the first product from Cisco where Cisco has said, we are not gonna marry you to Cisco infrastructure. We're not gonna force you to deploy policy or to deploy anything in any way that you don't want to do. We're going to give you the flexibility to deploy this and use this any way that you need to, right? And that's what I really want to get across. Then the last thing I want to talk about here, and I'll end the video here and then we'll jump into a demo called Workload Profile, so look for that one next, is Cisco Ice. This is quite possibly my personal favorite because not only can I gain visibility and create policy based on user, but I can also do it based on SGT, which means that when these security groups change, my policy can dynamically change with it. If you guys remember the very first slide, I had Stealth Watch in there, right? Stealth Watch. We could spell, that'd be great. So imagine that Stealth Watch is out there and it's looking for any type of anomalies in your environment, right? It's looking in your network for any type of bad guy, right? And all of a sudden it identifies that, hey, I'm seeing some malicious traffic coming from JP's laptop, okay? Now I have Ice. I have, JP when he authenticates, he's authenticating against Ice, but maybe not everywhere in my infrastructure is able to support security group tags. In other words, maybe I'm not able to quarantine JP from every area of my network, only most of it, but there still are areas where I might be vulnerable, right? Well, because Stealth Watch, Ice, and Tetration, they can all integrate, and by the way, they can integrate through SecureX, which is really, really cool. You can leverage SecureX to do a complete workflow through the three of these, or you can just, again, directly integrate Cisco Ice with Tetration, and then Stealth Watch integrates with Ice. So Ice now acting as the middleman, when Stealth Watch identifies that JP is now bad, it changed my security group to bad. Maybe I was an employee before, now my security group is bad. What happens in Tetration? Well, in Tetration, I have a policy that says if SGT equals bad, deny. Simple. It's one line of code. It's one line of policy across what could be 15,000 endpoints in my data center, 15,000 workloads across hybrid cloud. So I could have workloads in AWS, VMware, all over the place, right? But I don't care, and neither does Tetration. Tetration now takes this change. When Ice changes my security group to bad, that change is made in Tetration, where now that bad group, which was previously empty, now has my IP address, right? Tetration now denies access to my particular IP address, right? And this is where all of this starts to come together. Again, it's not just a software sensor in one place. It's not just a hardware sensor everywhere. Give me NetFlow. True security posture, creating a real security policy in your environment, truly being able to lock down your network is so much more than just simply, okay, I'm going to deploy a firewall, or I'm going to deploy a software sensor, or I'm going to deploy a hardware sensor, whatever. Tetration is so much more than that. So in the next video, what I'm going to do, I'm going to end it here. In the next video, what I'm going to do is we're going to take a look at the workload profile and all of the data that we're actually gathering from the different sensors. See you guys there. Bye-bye.